So yeah, thanks everybody for joining. I think this is everybody, so let's start already. I'm recording this session, so we're going to share this publicly. The idea of this session is to discuss specifically the technical requirements for the DevNet and to get any questions from you guys and answer them. So maybe let's start already. I'll give the mic to Basti, who is going to be talking about that.
Yeah. Hi, everybody. So first of all, I am here with Philipp and Sergio and myself, and then we also have Bruno on this call, so that you guys know who you are dealing with. And I want to say like 2 weeks ago or something, we talked about in the Coders Dojo that we would publish sort of lists of stuff that we consider necessary to release DevNet, and we sat together and did that list. And we are now going to give you like a high-level overview over what we came up with. But at the same time, a lot of these items are classified as a requirement for DevNet, even though they are already done and no longer like require any work, at least for now. So like the most high level overview of it is basically it needs to be a working client that performs at least like halfway decent to our expectations in a like good environment. So we are not talking about like any opponents to the network that are trying to like do malicious attacks or something. So hardening in general is not going to be part of DevNet. There are some instances where we included it, but generally speaking, we are not going to put any effort in that before we release DevNet. So the next thing that we came up with is that we want basically the network to be able for now to run without malicious attacks, performing all basic interactions that are necessary for the general operation of the network for up to, once it runs for 3 days, basically without crashing, then we are going to release public seed nodes for that net. So that includes, it's certainly not limited to like all these interactions that you can do with the staking contract, like registering and dropping and stuff of validators, parking, automatically unparking, all these things, obviously sending transactions. Now, to go a little bit more into detail for the specific items that are contributing to this, let's start with the network. So the network obviously needs to perform a couple of things, like connecting to different nodes and discovering addresses of peers. Like these basic functions all need to be there. However, what we are not going to include are any sort of denial of service attack protections or any net traversal either. There is also in the DevNet most likely not going to be any banning of peers for misbehavior. That is certainly something that we are going to add later on, but not for the first release of DevNet. And then what it needs to be able to do is to recover from network outages. So any node or any like network split or something, these kinds of things it needs to be able to resolve them eventually. So then we have the blockchain as the next component, and the blockchain basically just needs to be able to extend and rebranch with a new block announcement or with a newly produced block, and it needs to be working with the history string. We have, I don't think we have like put any block time in our requirements because basically the performance optimizations are also not necessarily the highest up the list as of now. But I'll talk a little bit more about that in a minute. So blockchain, that is pretty much all done. The extend and rebranch does work, and it does work with the history sync either. Unfortunately, I created a deadlock, but that is also going to be resolved hopefully very soon. Yeah, and okay, moving up the list, we come basically to our accounts tree, and there are basically everything with a staking contract, which is one of the items on that tree. All of those interactions need to work. I think they pretty much all do. So there's also not a whole lot of work to do there. And then all other contract types need to work as well. However, there are not all that many contract types on the Nimiq network in general. So, and I think they work as well. So that is all pretty much done already. But the next big topic would be the mempool. And the mempool obviously is not done. The current implementation that we are using right now is the port from the Nimiq 1.0 chain to Rust, and is very, very slow. So we started implementing the new mempool like 2 weeks ago or something. And we set the requirement for that our blockchain would need to be able to do roughly 100 TPS, which that is, at least from our point of view, like a very low bar that we should absolutely reach. And these 100 transactions per second, of course, also tie in a little bit to the blockchain, because block times do also play a part here. So there's a little bit of performance that we do require in this regard. And then there's finally the validator. The validator needs to be able to find all other validators and connect to them so that they can produce macro blocks. They also need to produce microblocks, of course. They need to be able to handle view changes in all kinds of situations, multiple view changes on the same block height, stuff like that. There's different situations that needs to be covered. Not all of them are tested, but the validator in our current setup works quite well. It for the more obscure kind of situations, we need to do some more testing, and it will probably also require some work, but the validator in general is, I think, in a pretty good state. What is missing from the validator though is the unpark, as far as I know. Sergio is working on that, and I think it should like hit main branch also like very soon. And then there's the RPC server and the metric server. And for the RPC server, that is basically the requirement for the RPC server is that the basic functionalities and basic RPC calls that you guys in particular need to interact with the blockchain, they all need to be there, because otherwise nobody can do something with it. So they need to be done. However, the metric server itself is out of scope, and we are most likely not going to include any version of it for definite. And when it comes to RPC, we also want to make sure that the API for those RPC calls is actually stable. So that once you start using definite to implement your things, that we don't introduce any breaking changes that basically invalidates a bunch of work that you guys put into it. And then lastly, as I have like alluded to a little bit before, the performance optimizations are not going to be a part of it outside of when they break the client. So in particular, if a memory leak exists, but is tiny and the client keeps on running for 3 days, we are still going to release it. If that memory leak is going to break the client within that time, we will have to fix it. So that is basically the list that we came up with. A lot of these things have already been done, and like there's obviously like a couple of things that are still a work in progress. But I think that is actually like setting the bar to a like reasonably low, how do you say that? Like a amount, level. That is still like a functioning product. So yeah, I think that is mostly it. Did I forget something? Anything to add, maybe?
Yeah, maybe it's just to also motivate us a little bit. I guess the idea with kind of cutting it down to the basics is to get it out as quickly as possible, right?
Yeah.
So it's not about like basically leaving like removing stuff like entirely, but it's more about priorities, right? What we want to have done first and what we want to have done quickly, basically to get it working. You know, when it just runs and we have a DevNet that just works and that you can connect to and send stuff around and it doesn't break, right? In a good weather setting, basically, and to have public DevNet nodes. And I think that's the motivation why we basically cut down the requirements to a pretty basic set for now. But that should be good enough to get to get it off the ground and then work from there, basically.
So yeah, then we started putting our stuff on GitHub, obviously. As we said last time, we are not completely done with that yet. That is probably also going to remain a work in progress forever, because we are always going to be adding new stuff there. But yeah, that mostly concludes our overview over this. Now we are here to talk with you guys about it.
Yeah, so first of all, great summary in my opinion. Good to hear that you guys, pick a list or set up requirements, the stuff you want to achieve to get, the first version out like the DevNet. I have two questions that came up instantly. The first one is for the network. So what kind of setup are you planning to use? Because you said it has to run at least for 3 days. So what kind of setups are you guys planning? Is it a real life example or scenario, or can you imagine it's not really a Docker setup?
So that is not strictly defined. I could certainly see, for example, us setting up 3 or 4 actual nodes and have them run. Once we see that it runs locally on our machines very well, then I could totally see us doing that. And potentially, depending on how good it runs, even publishing them then once it has been running for a couple of days. But it is really that is really not set in stone. And to allude a little bit, basically the whole infrastructure topic is not something that we focus on a lot, because before we are going to look into how to set this up and where to locate those nodes and all these kinds of things, I think there's more interesting questions to be answered before or more pressing issues to tackle, and the infrastructure will then basically grow as we have demand for it. And but for basically the tests, I think we will have something maybe amongst the team that can fulfill that criteria.
I think for the real DevNet, we are not going to be using the Docker setup.
No.
So just to clarify that, I mean, it's not going to be like a demo thing, but those are going to be actual distinct nodes, not in a virtual environment, basically.
Yeah, so DevNet will definitely live on distinct servers with actual seed nodes, public seed node addresses, for sure. That's for sure.
Okay, cool. Go ahead.
Yes, thank you for the summary. I see on the GitHub there is on the project page with information about it. It says on the network it handle at least 100 nodes in the network. Are you going to plan to try to set up 100 nodes, or do you want us to set up a lot of nodes, or do you want to see that happen?
So you mean how are we going to test for that?
Yeah, exactly.
We haven't defined that yet. I guess it will probably resolve around having some virtual setup where we can just spawn a bunch of nodes. Mm-hmm. This requirement also kind of, it's kind of kind of a low bar requirement. I mean, our current client can handle, I think the config is like 4,000 nodes, like by default. So I also expect this to be, not something that we are going to be put like a lot of effort into to get like the 100 nodes. But yeah, there's no clear plan yet on how to test this, but it's probably not going to be like it's probably going to become some cloud services that we're going to use to spawn like a bunch of nodes. I think that's the most likely way, I guess.
Yeah. But also, this also goes back to like us for now not putting a lot of thought into infrastructure. We are just going to probably make our lives easy in that regard and just spawn something on some virtual like things and be done with it.
Yeah, I think we can make a DigitalOcean droplet of or something, or an AMI for AWS, something like that.
Yeah, exactly.
Or we can build some Terraform code to deploy a bunch of stuff.
Well, maybe, I don't know, maybe even like just announcing it in the Coders Dojo and team internally and some other like inclined people might actually also get us there. We will see. Might also be fun. So
as you guys are still defining the API of the RPC server, and you don't want to, make it breaking, is it an idea that, the community can help in that sense? Doing suggestions or contributions in, helping finalizing the API for the RPC server?
Actually, guys could help you. That's my next task, to work on the RPC. There's an issue for the RPC repo. I think it is not repo, correct, sorry. 229, I think it's the issue. And if you guys have any suggestions, just write in there, and I'll basically take it in account. I'll share the link in here.
Yeah, 229. Yes.
I'll open a PR at a given point, and then you guys can also share suggestions in there. But yeah, if there's any method that you guys need, just ask me, and I'll add it. If it makes sense, of course.
Did you do any DevNet testing long term internally already? Because for A staking, we running a node or a DevNet setup, like the Docker Compose setup for days, and it works fine. But it only doesn't work if there's now a deadlock issue with if you do a lot of staking and stuff, then there's a deadlock issue. But for the rest, we run it for like weeks at a time. Yeah. Most of the time, what we do is if Jake made a new version of the pool software, I update my server, and we sync the main branch and the pool implementation, and then let it run for a week, and then see what is happening.
So the client does outside of the deadlock. Sorry, my bad. Going to fix it. Thanks, Jake, by the way. Yeah, outside of that, it does run very smoothly. I had it run for, I think, like 1.5 weeks straight almost. So basically, it stops when I stop it. So that is certainly a good thing. However, that is under no load whatsoever. There's no transaction on the network in the basic setup. And once you start actually like putting a lot of transactions in there and like perform some of the tasks that for example, the staking contract needs to take care of, there are still cases where this is like really not up to speed and is in dire need of improving. The mempool in particular is really bad as it is currently. So I'm really happy that that is being upgraded now, or like pretty much redone in a lot better way. So just running the Docker setup is from our point of view not sufficient criteria, because it just covers so little functionality. And thus we tried to come up with like a better test scenario. Maybe we can even like try and get an actual scenario up that needs to run for 3 days, that does do some basic interactions. Maybe not like spam the network like a madman, but at least like interact with it to a reasonable extent. And that the network still struggles with.
Okay, maybe to expand also on this a little bit. Generally, as also outlined in the document, the 3 days we want them to be under load, because I mean, we want to see how the network performs when it's under stress. But right now, our internal load testing is still kind of lacking a little bit. And we are right now creating better tools to also enable everybody to better load test locally, also with a non-Docker setup that's a little bit more lightweight, in order to find issues more quickly, just like this deadlock, which now basically would have caught if we had load test more this better. Generally on the front, we still need to make some improvements.
Yeah, Jake is making a performance testing tool for our pool, because we want to know how a pool works. That's how we found the deadlock. I think he's also making a proposal to make it for the community funding board, and so everyone can use it for DevNet and testnet in the future.
Very cool idea.
Yeah, definitely.
Maybe you can elaborate a bit, or.
Yeah, I don't know if you can hear me properly.
Yeah.
Cool. Yeah, I indeed worked briefly on a testing tool. There's the same testing tool that I also use to debug the stall of the chain regarding the network. And now also indeed I found a deadlock with it. But considering that I didn't really spend too much time on it yet, because it's pretty difficult to test performance when you already know that the mempool and the deadlocks are in place. So just wait till those are fixed and see if I can create a application to do some simulating on the staking contract transactions. So the plan was actually to create stakers and have dedicated processes to randomly unstake, retire, moving the stake to a different validator, just to have some scenarios and see how the pool in our case handles stakers that leave the validator or join the validator or some stuff like that. So that was basically the idea.
Sounds really cool, for sure.
How is the current mempool implementation differs from the ones you're now rebuilding, basically?
Okay, so I guess first of all, the old mempool implementation was really pretty basic. It was heavily inspired by the JavaScript implementation. It was pretty much, a pretty straightforward port from the old JavaScript implementation. And for example, and one of the key issues right now is that it doesn't make proper use of parallelization. So the way that it is structured, and also the way that it interacts with the blockchain, or the way it used to interact with the blockchain, made it very hard to basically parallelize the stuff. That also motivated some of the other changes that now introduced the deadlock, where we modified the way that we lock the blockchain data structure to make mempool interactions with the blockchain more efficient. Then another key difference between the new implementation and the old implementation is that the old mempool implementation actually provided a consistent state, in the sense that at any point in time, the miner or validator could pull out a bunch of transactions and include them in the block, and they would apply without error, basically. So that meant that the mempool needed to check a bunch of stuff in order to make sure that that there are no conflicting transactions in the mempool. And at the same time, the mempool in the mempool implementation, we didn't want to make assumptions about how accounts worked. So ultimately, the mempool had to kind of virtually apply the transactions to the accounts state, which is pretty expensive, right? Like simulating a bunch of transactions. So we are moving away from providing those guarantees in the new mempool, and they pretty much only cut down all checks to, signature verification, obviously, and then only making sure that the fee for the transaction can be paid, and that we have sufficient balance to include the transaction in the mempool, and then defer the consistency checks to when we actually pull out the transactions into the block, or to include them in the block. Yeah, that's kind of roughly other changes that we're doing to the mempool. So we're parallelizing it, and we are making it faster by providing less consistency guarantees.
So those guarantees are checked on another place, I guess, then?
Those guarantees are checked on another place, but basically only for a very small subset of transactions, right? So we're not keeping the whole the mempool basically consistent, but only need to find a consistent subset of those transactions when we pull them out. And there are also there is also still the possibility, which we are not right now pursuing, because it has a bunch of changes. But what we could also, or what we're also considering, is instead of making sure that those transactions actually that those transactions are consistent, that they reside in a consistent state, we could also just include or let transactions fail. So they can be included in the block, but they are failing, like in Ethereum, basically, where we don't want to simulate beforehand if that transaction fails or not, because that would be as expensive as executing that transaction. So that could be a way to eliminate the consistency checks entirely, and that could then be an option to increase performance by allowing failing transactions in blocks.
And as you're moving away those verifications in the mempool, can't that be like abused by people by like flooding the mempool, for example? So
we are still checking that you have enough balance, basically, and those verifications that we are doing are basically still sufficient. We actually can only. So how do I say this? I think the key aspect is now that we are basically now making more assumptions in the mempool about how accounts work. So instead of having a completely opaque view on accounts, and that included the fact that an inbound transaction increases the balance and an outbound transaction decreases the balance, that completely opaque view required us to kind of run a full simulation of what these transactions would do to the accounts tree. We're not doing that. We are basically just assuming, okay, if you do an outbound transaction, that decreases the balance and by the full transaction amount, fee plus amount, and we just check that right then and there, and don't basically run the full machinery of applying this transaction on the sender account and on the recipient account, which we now need to do for the staking contract, because there we have dependencies between two different inbound transactions into the staking contract. Dependencies which could basically invalidate one or the other transaction. And therefore, from a security point of view, the checks that we are now doing should be sufficient to basically prevent anybody from creating transactions in the mempool which we can't basically process. So if they're in the mempool and they're paid for, and we can include them, they're good. And all those transactions, or the invariants that we are now guaranteeing for the mempool, still maintain that property.
Really cool. And like as you said, also reducing the amount of expensive computation that needs to be made in order to get it actually in the mempool.
Mm-hmm. Exactly. Yeah. Mm-hmm.
Okay, cool. Thanks for the insight.
So are there any definitions on a healthy load? Do we have a nice definition of it for the DevNet?
We don't have one yet, I guess, but we could probably define it at
because we can make it under stress with a lot of wallets and stuff, but creating and opening and unlocking and sending transactions on a seed node is pretty expensive now, like resource-wise. So if you have a lot of accounts opening on one seed node, it uses a lot of resources. So
what do you mean if you create like a lot of accounts in the wallet, or
no, at the seed node? So if you use the RPC calls to create a new wallet and to unlock it and send a transaction, so it gets funds and do a staking transaction. If you make a lot of them, it's a resource intensive operations for the seed node itself.
Basically sending out those transactions via RPC, you mean?
Yeah, exactly.
I think this is also something that we encountered during testing, and found that sending transactions via RPC isn't really efficient enough right now. Also, in order to induce basically sufficient load to even basically get the network to its limits. I think a lot of those issues that we are seeing, and that also includes the deadlock, for example, are going to go away with the new mempool, because the mempool right now, it also sits in this particular code path. So when you're sending a transaction, it actually gets pushed into your local mempool, and which in this case is not even necessary, because that node isn't a validator. So one thing that also changes with the new mempool is that it sort of becomes part of the validator in the logical sense. So it moves away from being part of the consensus logic to something that only the validator is concerned with, because only the validator is going to actually need to cache those transactions. And nano clients, they need something. They don't need like a mempool like the validator does. So that's also maybe a little bit different from the old implementation, where we sort of had mempools also for the nano nodes, because it was required to relay transactions to the network, which we don't need anymore right now. So if you want to improve that particular code path, you can basically just remove the push transaction to the mempool part, and reduce it to just publishing the transaction on the transaction topic, and completely bypass the mempool, because it still works.
Oh, okay.
So you can just do network gossip sub publish instead of consensus and transaction, basically.
Yeah, that gives you basically an order of magnitude at least.
Yeah.
Okay, thanks.
So since there are like not more questions, I think. I was thinking of some lighter question. How is it to have everybody together again in the hackathon? Most of the team members together and working. How is it going there?
It is really awesome. It is really cool, like having everybody together. And obviously, we also have 2 new team members that me personally, for example, I haven't seen them before in person. So it's really, really nice to get to know each other, of course, and spend some time with each other. And like all sitting in one room certainly gives a very nice energy to that room, if I may say so. It's really, really cool, for sure.
It does feel like a big LAN party.
Yeah.
Kind of. Yeah.
Yeah, there's like I want to say it's like a pretty big room actually, but I think at peak we were like 16 people in here, so it was pretty nice. Yeah, it was cozy. That's great. Right, Richy?
Yeah, it was great. He says was because today I basically had to travel from the hackathon to Berlin to meet some guys here. So yeah, we're related not to technical issues, but actually more of marketing matters. I'm meeting here our marketing agency, and also some people are going to help us potentially recording part of the blockchains meeting, conference. So I'm no longer with the guys, but it was amazing. Yeah, and looking forward for another hackathon here in Germany. Okay, so I think if there are no more questions, then maybe we can start wrapping it up. Thanks everybody for joining. We mentioned many times in this call a document, which is the document where the guys from the blockchain team are basically aggregating all the milestones and the issues to be solved towards a DevNet. We're going to share the link for this project in the description of the video. And for everybody to see, the developers of this call already have access to it. And if you have any other questions or feedback, feel welcome to just share it in the Coders Dojo. The guys are going to be there active answering your questions. And thank you for joining. Hope to see you in the next one.
Before we wrap up, I wanted to give a quick shout out to Jake. Thanks a lot for the contributions and for the bug reports. They are really helping out a lot.
Definitely, yeah.
True.
Actually, I was under the impression that you might actually visit us during the hackathon, but that sadly didn't came to pass, I think.
Yeah, that is something that
you're welcome. And secondly, I wasn't aware of the hackathon.
I think you're confusing Jake with Stefan.
That might be the case. Yeah, that might be the case.
Yeah, who was considering to visit us, but yeah, we're discussing about maybe a future hackathon or meetup, so everybody can meet and actually get some stuff done and hack a little bit with the DevNet or testnet.
Oh yeah, with so many people being located in the Netherlands, maybe we should just like go and visit.
Yeah, that would be nice. Yeah.
It would be fun if we could set up a testnet or something, or the hackathon with testnet. Then we can stretch all our tools and implementations of applications. Maybe that's something nice.
For sure, that is something that we've been discussing and considering for the future. When we get to that point, it would be great to have all these tests and I guess stress tests and simulations with people in the same room and just talking about it and solving all the issues that present themselves. So it would be great to do something like that. Let's look forward to that and start planning. But of course, main thing here is first to get to the DevNet. And yeah, thanks for the guys from the blockchain team to join us. And thanks, Jake. I've also been hearing a lot of amazing things from you and from Maestro and Nice Mining, and also from the rest of the developers. It's always great to have your support.
Definitely.
Thanks a lot, guys.
Yeah, thanks so much.
Thank you too.
Thanks for the time, guys.
Thank you.
Thank you. Talk to you soon.
See you guys.
Thank you. See you in the next one. Bye.
Talk to you soon. Bye-bye.
Bye.
Bye.